Aura Components Basics. Connect components with events. Learning objectives. After completing this unit, you'll be able to define custom events for your apps, create and fire events from a component controller, create action handlers to catch and handle events that other components send, and refactor a big component into smaller components. Connect components with events. In this unit, we're going to tackle the last piece of unfinished functionality in our little expenses app, the reimbursed checkbox. You're probably thinking that implementing a checkbox would be a short topic. We could certainly take some shortcuts and make it a very short topic. But this unit, in addition to making that checkbox work, is about removing all of the shortcuts we've already taken. We're going to spend this unit doing it the right way, which in a few places means refactoring work we did earlier. Before we start on that, let's first talk about the shortcuts we took, the right way, and why the right way is a little bit harder, but also better. Composition and decomposition. If you take a look at our little expenses app in source code form and list the separate code artifacts, you'll come up with something like the following. Expenses component, expenses.cmp, expensescontroller.js, expenseshelper.js, expenses list component, expenses list.cmp, expense item component, expense item.cmp, expenses controller, server side, expenses controller.apex. Here's how everything comes together with the create expense and update expense events you're wiring up later. But if you look at the app on screen, what do you see? What you should see, and what you'll eventually see everywhere you look, is that the app breaks down into many more components. You'll see that you can decompose our app further into smaller pieces than we've done so far. At the very least, we hope you see that the add expense form really should be its own separate component. That's why we drew a box around it in the user interface. Why didn't we make that form a separate component? Not doing that is by far the biggest shortcut we took over the course of this module. It's worse than the hack we call disgusting in terms of software design. The right way to build a Lightning Components app is to create independent components and then compose them together to build new, higher level features. Why didn't we take that approach? We took the shortcut. We kept the add expense form inside the main expenses component because it kept the main expenses array component attribute and the controller code that affected it in the same component. We wanted the create expense helper function to be able to touch the expenses array directly. If we'd moved the add expense form into a separate component, that wouldn't have been possible. Why not? We covered the reason briefly very early on, but we want to really hammer on it now. Lightning components are supposed to be self-contained. They are standalone elements that encapsulate all of their essential functionality. A component is not allowed to reach into another component, even a child component, and alter its internals. There are two principal ways to interact with or affect another component. The first way is one we've seen and done quite a bit of already, setting attributes on the component's tag. A component's public attributes constitute one part of its API. The second way to interact with a component is through events. Like attributes, components declare the events they send out and the events they can handle. Like attributes, these public events constitute a part of the component's public API. We've actually used and handled events already, but the events have been hiding behind some convenience feature. In this unit, we'll drag events out into the light and create a few of our own. The wiring a circuit metaphor, yet again. These two mechanisms, attributes and events, are the API sockets, the ways you connect components together to form complete circuits. Events are also behind the scenes, the electrons flowing through that circuit. But that's only one way that events are different from attributes. When you set the onClick attribute on a lightning button to an action handler in a component's controller, you create a direct relationship between those two components. They are linked, and while they're using public APIs to remain independent of each other, they're still coupled. Events are different. Components don't send events to another component. That's not how events work. Components broadcast events of a particular type. If there's a component that responds to that type of event, and if that component hears your event, then it will act on it. You can think of the difference between attributes and events as the difference between wired circuits and wireless circuits. And we're not talking about wireless phones here. One component doesn't get the number for another component and call it up. That would be an attribute. No, events are like wireless broadcasts. Your component gets on the radio and sends out a message. Is there anyone out there with their radio set, turned on, and tuned to the right frequency? Your component has no way of knowing, so you should write your components in such a way that it's okay if no one hears the events they broadcast. That is, things might not work, but nothing should crash. Sending an event from a component. Okay, enough theory. Let's do something specific with our app and see how events work in code. We will start by implementing the reimbursed checkbox. Then we'll take what we learned doing that and use it to refactor the add expense form into its own component the way the great engineer intended. First, let's focus on the click handler on the lightning : input for the reimbursed _C field. Before we dive into the click handler, let's take a step back and catch a glimpse on what lightning::input has to offer. Type equals toggle is really a checkbox with a toggle switch design. Class enables you to apply custom CSS styling or use SLDS utilities. Message toggle active and message toggle interactive provides a custom label for the checked and unchecked positions. These handy attributes are only several of many others on lightning::input. Finally, the onChange attribute of lightning::input gives us an easy way to wire the toggle switch to an action handler that updates the record when you slide right, checked, or slide left, unchecked. Now let's think about what should happen when it's checked or unchecked. Based on the code we wrote to create a new expense, updating an expense is probably something like this. Number 1, get the expense item that changed. Number 2, create a server action to update the underlying expense record. Number 3, package expense into the action. Number 4, set up a callback to handle the response. Number 5, fire the action, sending the request to the server. And number 6, when the response comes and the callback runs, update the expenses attribute. What expenses attribute? Look at our component markup again. No expenses, just a singular expense. Right? This component is just for a single item. There's an expenses attribute on the expenses list component, but that's not even the real expenses. The real one is a component attribute and the top level expenses component. Is there a component.get v.parent? Or would it have to be component.get v.parent.get v.parent? Something that would let us get a reference to our parent's parent so we can set expenses there? Stop. Right there. Components do not reach into other components and set values on them. There's no way to say, hey, grandparent, I'm going to update expenses. Components keep their hands to themselves. When a component wants an ancestor component to make a change to something, it asks nicely by sending an event. Here's the cool part. Sending an event looks almost the same as handling the update directly. Here's the code for the ClickReimbursed handler. Whoa, that's pretty simple. And it does look kind of like what we envisioned above. The preceding code for ClickReimbursed does the following. Number 1, it gets the expense that changed. Number 2, it creates an event named update expense. Number 3, it packages expense into the event. And number 4, it fires the event. The callback stuff is missing, but otherwise this is familiar. But what's going on to handle calling the server and the server response and update the main expense array attribute? And how do we know about this update expense event anyway? Update expense is a custom event, that is, an event we write ourselves. You can tell because, unlike getting a server action, we use component.getEvent instead of component.get. Also, what we are getting doesn't have a value provider, just a name. We'll define this event in just a moment. As for what's going on to handle calling the server and handling the response, let's talk about it. We could implement the server request and handle the response right here in the expense item component. Then we'd send an event just to re-render things that depend on the expense array. That would be a perfectly valid design choice and would keep the expense item component totally self-contained, which is desirable. However, as we'll see, the code for creating a new expense and the code for updating an existing expense are very similar, enough so that we prefer to avoid duplicate code. So the design choice we've made is to send an update expense event, which the main expenses component will handle. Later, when we refactor our form, we'll do the same for creating a new expense. By having all child components delegate responsibility for handling server requests and for managing the expenses array attribute, we're breaking encapsulation a bit. But if you think of these child components as the internal implementation details of the expenses component, that's okay. The main expenses component is self-contained. You have a choice. Consolidation of critical logic or encapsulation. You'll make trade-offs in Aura components, just like you make trade-offs in any software design. Just make sure you document the details. Defining an event. The first thing we'll do is define our custom event. In the developer console, select File, New, Lightning Event, and name the event Expenses Item Update. Replace the default contents with the following markup. There are two types of events, component and application. Here we're using a component event because we want an ancestor component to catch and handle the event. An ancestor component is a component above this one in the component hierarchy. If we wanted a general broadcast kind of event where any component could receive it, we'd use an application event instead. The full differences and correct usage of application versus component events isn't something we're able to get into here. It's more of an advanced topic, and there are enough complicated details that it's a distraction from our purpose in this module. When you're ready for more, the resources will help you out. The other thing to notice about the event is how compact the definition is. We named the event when it was created, expenses item update, and its markup is a beginning and ending aura colon event tag and one aura colon attribute tag. An event's attributes describe the payload it can carry. In the ClickReimbursed action handler, we set the payload with a call to set params. Here, in the event definition, we see how the event parameter is defined and that there are no other valid parameters. And that's pretty much all there is to defining events. You don't add implementation or behavior details to events themselves. They're just packages. In fact, some events don't have any parameters at all. They're just messages. This happened. All of the behavior about what to do if this happens is defined in the components that send and receive the event. Sending an event. We've already looked at how to actually fire an event in the ClickReimbursed action handler. But for that to work, we need to do one last thing, and that's register the event. Add this line of markup to the expense item component right below its attribute definitions. This markup says that our component fires an event named update expense of type C:expenses item update. But wasn't expenses item update the name of the event when we defined it? And what happened to component or application event types? You're right to think it's a little confusing and really is a bit of a switcheroo. It might help to think of application and component as Aura components framework event types, while the types that come from the names of events you define are custom event types or event structure types. That is, when you define an event, you define a package format. When you register to send an event, you declare what format it uses. The process of defining and registering an event might still seem a bit weird, so let's look ahead a bit. Here in the expenses item, we're going to send an event named update expense. Later in the expense form, we're going to send an event named create expense. Both of these events need to include an expense to be saved to the server, and so they both use the C:expenses item update event type or package format to send their events. On the receiving end, our main expenses component is going to register to handle both of these events. Although the server call ends up being the same, the user interface updates are slightly different. So how does expenses know whether to create or update the expense in the C:expenses item update package? By the name of the event being sent. Understand the distinction here, and how one event can be used for multiple purposes is a light bulb moment in learning Lightning components. If you haven't had that moment quite yet, you'll have it when you look at the rest of the code. Before we move on to handling events, let's summarize what it takes to send them. First, define a custom event by creating a Lightning event, give it a name and attributes. Second, register your Lightning component to send these events by choosing a custom event type and giving this specific use of that type a name. Third, fire the event in your controller or helper code by 3A, using component.getEvent to create a specific event instance, or 3B, sending the event with fire. If you went ahead and completed all of the code we just looked at, you can test it out, reload your app, and toggle a reimbursed checkbox a few times. If you missed a step, you'll get an error and you should recheck your work. If you did everything right, hey, wait, the expense changes colors to show its reimbursed status just as expected. This behavior was present before we even started this unit. That's the effect of the Lightning :input component having value equals open curly bracket bang v dot expense dot reimburse double underscore c close curly bracket set. When you toggle the switch, the local version of the expense is updated, but that change isn't being sent up to the server. If you look at the expense record in Salesforce or reload the app, you won't see the change. Why not? We've only done half of the work to create a complete circuit for our event. We have to finish wiring the circuit by creating the event handler on the other side. That event handler will take care of sending the change to the server and making the update durable. Handling an event. Enabling the expense item component to send an event required 3 steps. Enabling the expenses component to receive and handle these events requires 3 parallel steps. First, define a custom event. We've already done this because expense item is sending the same custom event that expenses is receiving. Second, register the component to handle the event. This maps the event to an action handler. Third, actually handle the event in an action handler. Since we've already done step 1, let's immediately turn to step 2 and register expenses to receive and handle the update expense event. Like registering to send an event, registering to handle one is a single line of markup, which you should add to the expenses component right after the init handler. Like the init handler, this uses the aura:handler tag and has an action attribute that sets the controller action handler for the event. Like when you registered the event in expense item, here you set the name and type of the event, though note the use of the much more sensibly named event attribute for the type. In other words, there's not much here you haven't seen before. What's new and specific to handling custom events is the combination of the attributes and knowing how the receiver socket in the expenses matches up with the sender socket and expense item. This completes the wiring part of making this work. All that's left is to actually write the action handler. We'll start with the handle update expense action handler. Here's the code, and be sure to put it right under the click create action handler. Huh, that's interesting. Except for the form validation check and the specific helper function we're delegating the work to, it looks like this action handler is the same as handle create expense. Now let's add the update expense helper function. As we did with the action handler, make sure to put this code right below the create expense helper function. Two things you should notice right off the bat. First, except for the callback specifics, the update expense helper method is identical to the create expense helper method. That smells like opportunity. Second, about those callback specifics, what gives? How can the right thing to do be nothing? Think about it for a moment. Earlier, when testing and sending the event, if not before, we saw that the expense item component's color changed in response to toggling the reimbursed checkbox. Remember the explanation? The local copy of the expense record is already updated. So, at least for the moment, when the server tells us it was successful at updating its version, we don't have anything to do. Note that this code only handles the case where the server is successful at updating the expense record. We definitely have some work to do if there was an error. Say accounting flagged this expense as non-reimbursable, making it impossible to set this field to true. But that, as they say, is a lesson for another day. Refactor the helping functions. Let's look back at that opportunity we saw to factor out some common code. The two helper functions are identical except for the callback. So let's make a new, more organized function that takes the callback as a parameter. The callback parameter is optional. If it's there, we'll pass it along to action. Simple. And now we can reduce our event-specific helper functions to the following code. Create expense is only a little shorter, but it's exclusively focused on what to do when the response comes back, the callback. And wow, update expense is a one-liner. Refactor the add expense form. That little refactoring exercise was so satisfying, and using events was so, electrifying. Let's do it again, but bigger. More cowbell. This next task involves extracting the add expense form from the expenses component and moving it into its own new component. Extracting the form markup is easy enough, a simple copy and paste exercise. But what else moves with it? Before we start moving pieces around willy-nilly, let's think about what moves and what stays. In the current design, the form's action handler, ClickReimbursed, handles the input validation, sending the request to the server and updating local state and user interface elements. The form will still need an action handler and should probably still handle form validation, but we'll plan on having the rest stay behind because we're keeping our server request logic consolidated in the expenses component. So there's a little, but only a little, teasing apart to do here. Our plan then is to start by moving the form markup and then move as little as possible after that to make it work correctly. We'll refactor both components to communicate via events instead of via direct access to the expenses array component attribute. Let's get started. In the main expenses component, select everything between the two create new expense comments and include the beginning and ending comments themselves. Cut it to your clipboard. Yes, cut. We're committed. Create a new Aura component and name it expense form. Paste the copied add expense form markup into the new component between the Aura component tags. Back to the expenses component. Add the new expense form component to the markup. That section of expenses should look like this. At this point, you can reload your app to see the changes. There should be no visible changes. But surprisingly, the Create Expense button no longer works. Let's get quickly through the rest of moving things around part. Next, move the new expense attribute from the expenses component to the expense form component markup. This is used for the form field, so it needs to be in the form component. It moves over with no changes required, so just cut from one and paste in the other. In the expense form component, create the controller and helper resources. Move the click create action handler from the expenses controller to the expense form controller. The button is in the form component, and so the action handler for the button needs to be there also. Believe it or not, this also needs no changes. You might begin sensing a theme here. Now we need to make a couple of actual changes, but these will be familiar because we're just adding event sending, which we did before for expense item. Expense item, you'll recall, also sends an event with the expense payload, which is handled by the expenses component. In the expense form helper, create the create expense function. This looks very much like the ClickReimbursed action handler in expense item. If a component is going to send an event, it needs to register the event. Add the following to the expense form component markup, just below the new expense attribute. At this point, we've done all the work to implement the expense form component. You should be able to reload the app, and the form now works in the sense that there are no errors, and you should see the appropriate form messages when you enter invalid data. If you're using the Salesforce Lightning Inspector, you can even see that the expenses item update event is being fired. All that's left is to handle it. Before we handle the event, please do notice how easy this refactoring was. Most of the code didn't change. There's a total of 6 lines of new code and markup in the preceding steps. It's unfamiliar to do this work today, but do it a few times and you realize that you're just moving a bit of code around. Okay, let's finish this. The expense form fires the create expense event, but we also need the expenses component to catch it. First, we register the create expense event handler and wire it to the handle create expense action handler. Once again, this is a single line of markup. Add this line right above or below the update expense event handler. Finally, for the last step, create the handle create expense action handler and the expenses controller. Add this code right above or below the handle update expense action controller. Yep, that's simple. All of the work is delegated to the create expense helper function, and that didn't move or change. Our create expense action handler is just there to wire the right things together. And with that, we're finished, showing how to loosely couple components using events. Create and fire the event in one component, catch and handle it in another. Wireless circuits. Bonus lessons. Minor visual improvements. Before we head off into the sunset, or rather the challenge, here are 2 modest visual improvements. First, have you noticed that the reimbursed and relative date time labels are nearly invisible blue on a green background? If it's been bothering you, too, here's how to fix it. We've held off on having you do this until we'd refactored the form into its own component. In the expense item component, add a style resource by clicking the style button. Replace the default style rules with the following. Reload the app for a sweet eye strain relief. Last, we'd like to improve the layout of our app a little bit by adding a few container components. This last bit also gives you an opportunity to see the full expense component after all our changes. In the expense component, replace the expenses list markup with the following. The effects of the changes are to add some margins and padding and make the expenses list more narrow. The layout leaves room to put something over there on the right. In the next unit, we'll